Right, so another thing we can do with our aldehydes and ketones is form imines and enamines. So imines look something like this, where we have a double bond to a nitrogen now, right? That used to be double bond to an oxygen, but now it's doubly bound to a nitrogen. And then enamine is very similar, except this nitrogen up here now has two R groups. And so instead of having this double bond on this nitrogen that would force it to have a positive charge, the double bond actually goes next to it, right? Next to the carbon-carbon bond on there. And if you take an aldehyde or a ketone, you'll get an imine or enamine depending on what you add to it. So to form the imine, you add a primary amine, so only one R group, and of course a catalytic amount of acid. That'll kick out a water molecule and form your imine. If you add a secondary amine, so in this case, two R groups, only one hydrogen, catalytic amount of acid, remove a water molecule, you'll form an imine. Remind me, enamine. In general, the mechanisms are very similar to one another and similar to the previous step with the enamine. At one point, what you've got is this positive nitrogen. And what happens is some kind of base comes along, generally another amine or another molecule of the amine that you're using, and then essentially kind of does an E2 reaction, if you will, to form your enamine. Overall, the mechanism is very similar to the acetals and the hydrates that we learned about. So I'm not going to draw it all out here. Check out the work along for the mechanism.